Hello everyone, I'm Preetham and my project is all about reinforcement learning in Super Mario. So today we are going to be discussing about the problem statement, introduction to reinforcement learning, OpenAI Gym library, stable baselines library, proximal policy optimization algorithm, understanding about the reward function, a small demonstration of the project, and the future enhancements which can be made. So in the game Super Mario, the player takes the role of Mario and the objective is to race through the Mushroom Kingdom by evading, eliminating your enemies, and save Princess Peach. Mario's primary attack is simply jumping on the top of his enemies, which kills them. Aiding him in his quest are several superpowers. The flower transforms Mario into a Fire Mario, which allows him to throw fireballs. The superstar temporarily transforms Mario into an invincible Mario, granting him invincibility and allowing him to defeat most of the enemies just by touching him. Hitting the question block will produce a mushroom which transforms Mario into an adult Mario. This allows him to destroy the brick blocks. Mario can be hurt if he touches an enemy. If he takes a hit from an enemy as an adult Mario or Fiery Mario, he simply reverts back to regular Mario, and then the game continues as normal. However, if he takes a hit as regular Mario, or falls down a pit, or if the clock timer runs out, he loses a life and starts the game all over again. Introduction to reinforcement learning. One of the most interesting topics in machine learning is reinforcement learning. The main idea is that an agent tries to learn by interacting with an uncertain environment and then using the experience which it gains to optimize some goal which is given in the form of cumulative rewards. We all know that AI can do some pretty cool things when it comes to playing games. The awesome thing about reinforcement learning is that it can be used to play games in a whole heap of different open world environments, and the game which it is pretty good at playing is Super Mario. So the objective of this project is to create an AI bot which can learn to complete the game on its own. So the steps required to create an AI bot. So in order to train our reinforcement learning model to play Atari games, we first need to create an Atari environment. So to do so, we are going to be using OpenAI Gym environment. And then what we're going to do is build a deep learning model with TensorFlow, and then we'll set this up so that it works hand in hand with our Atari environment. And then the last but not the least, we will use a PPO reinforcement learning algorithm to train our AI model. So OpenAI. OpenAI Gem library is nothing but a toolkit that gives us a whole bunch of different environments that we can begin to play with. So in gem.openai.com, we will be focusing on the Super Mario environment, which will allow us to train a AI model which can eventually crush the game of Super Mario. Understanding the reward function. A reward function in layman terms is like thinking whether or not if you've done something right in the game. So if you've done a correct action, you will be rewarded by a point. In our case, the reward function main goal is to move Mario as far right as possible without dying, and also to increase the score we can collect as many coins as possible. So by doing this, we will increase the reward function of Mario by 1. If the bot falls down a pit or takes a hit from an enemy, then we reward the bot with 0. This effectively trains our AI bot to maximize the reward function for every episode. Stable baselines. So stable baselines is a reinforcement learning library which contains a whole bunch of different algorithms like A2C, DQN, PPO, TRPO, and etc. So we can use all these to train AI models. So in these, I have used PPO algorithm, which stands for Proximal Policy Optimization. PPO. So the intuition behind the PPO algorithm is that the policy should not change drastically after the updation of our parameters. PPO implements this intuition in a simple way, making it faster than other algorithms. In PPO implementation, we maintain 2 policy networks. The first one is the current policy, which we want to refine, and the second policy that we used last to collect the samples. With these 2 policies, we evaluate a new policy with the samples collected from an older policy. So for every small number of iterations, we synchronize the second network with the refined policy again. Training the model. The Super Mario agent was trained using visual inputs that are converted into grayscale, which are resized and frame stacked, which significantly reduces the size of our model. This makes the training faster without any major loss of information. So this is the saved model which was trained for 50,000 episodes, and we can see that the bot can't even clear the first enemy even after being trained for 50,000 iterations. The bot usually gets stuck at the first pipe for more than 3 million iterations. So after training the bot for 5 million iterations, it actually makes good progress but still fails to complete the level. So I actually ended up training this particular model for around 5 to 6 days. And then it happened. We got our dream run at around 9 million episodes. Mario crushed the first level by avoiding and eliminating the enemies. So after this, the Mario bot does make it through, but he gets stuck every once in a while. But the bot successfully completed the first level of the game on its own. Future enhancements. So what can be done is training the model using different reinforcement learning algorithms and then comparing the reward functions of each of them so as to choose the best algorithm for this project. But as there is very limited time constraint for this project, I wasn't able to implement this. However, I have achieved the main goal, which is inducing intelligence into the bot by creating a deep learning model to complete the level successfully. Please let me know if you guys have any other questions. Thank you.